All right, hi everyone. For chapter 2, we're going to talk about polynomial functions. But before we get to polynomials, I want to start off with a review of basically the simplest type of polynomial, and that's a quadratic. And you've covered this a lot before. This was covered throughout your last 3 years of math several times. But I want to review some of the important topics with you because this is going to be our fundamental building block that we start from. So first of all, this is what we call a quadratic. Basically, quadratic means polynomial of degree 2, and what that means is the highest power of x that you see anywhere is 2. It's basically anything with an x squared in it and nothing higher. Now, the form that you see on the presentation is called general form, and that's when you just list the terms in order from highest to lowest power. So you have your x squared part first, you have your x part in the middle, you have your constant term, which is the one that doesn't have an x last, and it's all equal to 0. Now, it is important that it's equal to 0. If you try to solve a quadratic that's not equal to 0, then it just doesn't work. The tricks that we are going to use to solve quadratics only work when it's equal to 0. So first of all, I'm going to talk about a couple special cases. So we had ax squared plus bx plus c equals 0. Well, let's say the constant term just isn't there. We can say c equals 0 or the constant term is missing. If that's the case, it's a very simple problem. Just factor out common terms. So for example, let's say we had 2x squared plus 8x equals 0, and we wanted to solve for x. And you notice it's missing a constant. It's not 2x squared plus 8x plus 10 equals 0. That constant term is missing. Now, because that constant term is missing, we can solve this one by factoring out common terms. So I'm going to set up my framework here. Now, factoring out common terms is basically like the distributive property, but backwards. Whereas the distributive property, you multiply something into the parentheses. Factoring out common terms, you divide it out. So my common term is going to be 2x. I can divide the 2 and the 8 by, the 2 and the 8 by 2. And I can divide the x squared and the x by x. So if I factor out the 2x, then basically 2x squared divided by 2x is just x. We still have that plus in the middle, and 8x divided by 2 is 4. And then once you've done that, now remember, you guys learned this in the past, but basically if you have a quadratic and it's equal to 0 and you factor it, you basically just separate and solve. And there's a shortcut to it, but just this once I'll show you the long version. What you're really saying here is either the thing I factored out, 2x equals 0, or the part left over in the parentheses, x plus 4 equals 0. And that's because of what's called the zero product property, and that's also why it has to equal 0. If you try to do this and it's equal to 10, there's no rule for that. But basically, if you factor something and you're multiplying them and the answer is 0, the only way that can happen is if one of those numbers was 0. And that's what we call the zero product property. So basically, divide by 2, x still equals 0 over here. Subtract 4, and x equals negative 4. So those are your two answers, 0 and negative 4. And I will say this, you've learned shortcuts. I don't expect to see all of this work in the middle. Like I said, I just showed you that once. The shortcut is anytime I factor out an x, whether it has a number in front of it or not, I can factor out x or 2x or negative 1 million x. If I factor out an x, that's always going to give you a solution of 0. And then for the other one, for the x plus 4 factor, the shortcut is basically just change the sign here. If you get x plus 4, the answer is negative 4. All right. Now the other special case is if b equals 0. So that middle term is missing. And here's an example of that. Last time we did 2x squared plus 8x equals 0, so the constant was missing. This time I basically just erased the x. And I said, what if it's 2x squared plus 8 equals 0? So you don't have that x term in the middle. And what I said in the notes is, in that case, don't even bother factoring. Just separate the terms and take the square roots. And actually, you know what? I'm going to make a change to this because the way it's written, it won't work out. So let's change that to a minus. Let's say it was 2x squared minus 8. And now, if I add 8 to both sides, this is what I mean by separate the terms. We'll have 2x squared equals 8. Divide by 2. We get x squared equals 4. Take a square root. Now, all you have to do for this type of problem is remember your plus or minus. Every time you take a square root, you get two answers, one for the plus, one for the minus. So my final answer here is going to be plus or minus 2. So those are just a couple of special cases when you're solving quadratics. If you happen to notice that you only have 2 of the 3 terms, do one of those 2 things. If you're missing the constant, factor out common terms. If you're missing the x term in the middle, don't factor at all, just separate and solve. But what we're going to really focus on is when all 3 terms are there. So we have our ax squared plus bx plus c. Every term is there. Maybe it says 2x squared plus 3x minus 10 equals 0. There are a few ways to solve. I'm going to go over 2 of them with you. Number 1 is factoring. And the way I like to present it is, if there's no number in front of x squared, I always at least try to factor first. Not every equation is factorable. That's why I said in the notes, if it's factorable. But you can try, because basically if something is factorable, factoring is usually the fastest way to solve it. Now, when there's no number in front of the x squared, it's one of those, it's kind of like a number puzzle. You're looking for the 2 numbers that multiply together to give you c, the constant term, and add together to give you b, the number in front of the x term. So let's do a quick one of those. We have x squared minus 7x plus 10 equals 0. So basically in this question, what I'm saying is that c equals 10 and b equals negative 7. Remember, it does keep the sign in front of it. The positive and negative signs are very important for this type of process. B isn't 7 in this question, it's negative 7. So what I can do is, if I can figure out the 2 numbers, I can jump straight to factored form, which will look like this. All I have to do is find 2 numbers where if I multiply them together, I get positive 10, and if I add them together, I get negative 7. And that would be negative 5 and 2, because negative 5 and negative 2. Negative 5 times negative 2 gives me positive 10, and negative 5 plus negative 2 gives me negative 7. So put each of those numbers after each x in either order. Maybe I'll put negative 5 on the first one, or minus 5, and minus 2 on the second one. Now you've factored, and then remember our little shortcut from before, just change the signs. So for my answers, x ends up equaling positive 5 and positive 2. So that's the guess and check way of doing factoring. You're looking for numbers that multiply together to give you c, add together to give you b, and if you can quickly run through the numbers in your head and come up with those 2, that's the fastest way to solve. Now, 2 things about that. Number 1, that process, that trick, doesn't work if there's a number in front of x squared. If this had been 2x squared minus 7x plus 10, it's a totally different question and you can't solve it that way. You can still do it by factoring, but it's much harder. Number 2, not every question is factorable. Sometimes there aren't 2 numbers that multiply together to give you c and add up to give you b. So those are the problems with factoring. Yeah, it is the quickest, but number 1, sometimes it's harder, and number 2, sometimes it just doesn't work. And that leads into the second method I wanted to review with you guys, the quadratic formula. So here's your nice familiar quadratic formula. I'm sure you guys know it already. Negative b plus or minus square root of b squared minus 4ac all over 2a. And actually, I said negative b. A better way of wording that would be to say the opposite of b, because if b is already a negative number, it turns positive. So you don't want to think it's always negative there. It's the opposite of whatever b was. Now, what I said for the notes is, if your equation is not factorable, or if you just don't want to factor it, you can use quadratic formula. So remember I said sometimes the factoring, like if you have a number in front of the x squared, a lot of times I go, forget it, let's just go quadratic formula. Factoring's hard, I'm not even going to mess with it. But that's up to you guys. The good thing about the quadratic formula, even though it is a little bit more work than factoring, it always works, no matter what. Any quadratic you ever try to solve, the quadratic formula will work. It will give you an answer no matter what. And that's what's good about it. Now, before I do an example with you guys, I want to talk about the discriminant. The discriminant is the little mini formula inside the quadratic formula. So if you think of the quadratic formula, that part that's inside the square root, b squared minus 4ac, is what we call the discriminant. And the discriminant, if you take a few seconds at the beginning of your problem to figure that part out before you do the whole thing, it tells you what type of answer you're going to get. So if you do b squared minus 4ac and you get a positive number, there are going to be two answers, period. If you get a positive number that's a perfect square, then it's actually factorable. And that's good to know. Remember, I told you back on the last slide, sometimes you're not sure if it's factorable or not. If you do b squared minus 4ac and you get any perfect square, that means 1, 4, 9, 16, 25, 36, any number squared, any whole number squared, that tells you it's factorable. Now, if it's positive but not a perfect square, that means it's not factorable and you have to do the quadratic formula. If you get a negative number, for now, we're just going to say no solutions. Although I know you guys learned complex numbers last year, we're going to review them a little bit later this chapter, and once we do that, we'll talk about those. But for now, if you get a negative for these, just say no solutions. Now, if you get a 0, you actually have exactly one answer. And what I want to do, real quickly, let's see if I can find some space in here. Negative b plus or minus something all over something, 2a. Now, here's what we're saying. If I get a positive number right there, then it's just an answer. It's two answers, one for the plus and one for the minus. If I get a perfect square, see how it's in the square root? The square root of a perfect square gives you a whole number, and that's why it ends up being factorable. Okay, so let's say we get a negative in there. You get the negative in there, all of a sudden you have a square root of a negative, that's no solutions for now. And the last possibility, we said, what if you get a 0 here? Well, the square root of 0 is 0, and it disappears. When the square root of, or when 0 disappears, it takes the plus or minus with it, because adding and subtracting 0 is the same thing. You only get one answer, and it's whatever this is right here. So when you're thinking of the discriminant, you don't have to like memorize it. You don't have to say, well, I have to remember what is, positive means this and negative means that. Just understand square roots, and it's very simple to see what the discriminant tells you. Square root of a negative, no solutions. Square root of 0 disappears, one solution. Square root of a positive number is just an answer. You get two answers. All right, so let's wrap it up with one quick example. One more quick example. We're going to solve for x right here, 6x squared plus x equals 12. And remember the very first thing I told you guys in today's video, it's not ready to solve. You can't ever solve a quadratic if it's not equal to 0. If I try to factor right now, whatever work I do is wasted time because factoring doesn't help you if it's not equal to 0. And the quadratic either. Quadratic formula, the equation has to be equal to 0 also. So before I do anything else, I'm going to start off this question by subtracting 12 from both sides because I want to cancel that out and make it a 0. So the equation I'm really solving here is 6x squared plus x minus 12 equals 0. And we look at that and we think, okay, well, that actually might be factorable, but I don't really want to even mess with it. I'm thinking to myself, I see that 6x squared, it's a lot of guessing. if I want to try to factor it. So I'm going to go straight to quadratic formula, which is, and I'll write it off to the side here, it's negative b plus or minus square root of b squared minus 4ac all over 2a. And in my question, now that I've got everything in the right order, I can see that a is 6, b is 1, and x by itself is 1x, so b is 1 in this problem, and c is negative 12. So let's do the work. The opposite of b would be negative 1 plus or minus square root of 1 squared minus 4 times 6 times, so that was a negative 12. Negative 12. And it's all over 2 times 6. So I'm going to do this. I'm going to leave the negative 1. I'm going to do 2 times 6 is 12. That's easy. Now inside the square root, we end up with 289. And you can use a calculator for that part. It's fine. But the square root of 289 is 17. That's a perfect square. So one thing that tells me is this question actually was factorable. Like I said, I still don't want to do it because there's too much guessing and checking involved, but you could have solved this one by factoring. Since we're already most of the way through, I'm just going to finish out the quadratic formula. Let's see if I can squeeze this in here. Negative 1 plus or minus, now remember we said that's a perfect square. The square root of 289 is just the number 17. It's not even a square root anymore. So we have negative 1 plus or minus 17, not the square root of 17, just the number 17, all over 12. And then once you get to that part, just do them separately. One with the plus and one with the minus. So one of my answers is going to be negative 1 plus 17 over 12. And the other one is going to be negative 1 minus 17 over 12. Negative 1 plus 17 is 16. 16 over 12, if you reduce by 4, would be 4/3. So one of my answers is 4/3. I know I'm kind of squeezing it in here. Negative 1 minus 17 would be negative 18 over 12. We can reduce that by a 6, and we get negative 3 over 2. So that's an example of the quadratic formula, and I hope today's notes were very easy for you guys. Remember, this is something you've learned several times in the past, but it's one of our most important skills. You got to be real comfortable solving quadratics before we can move into the harder stuff. So I decided to spend a day reviewing this. Hopefully it helped, and you guys have some practice problems to do. We can go over them in class tomorrow.